Hi everyone, so this is a quick video going over the interior angle theorem, which is just a continuation of working with angles inside circles. So a couple things before we start getting to answering these questions. Recognizing our first diagram, we know we're calling that circle T because the center point is labeled with that capital T. And then I have lines AD and line EC going through the circles and intersecting at that common point highlighted pink called B. Okay, so if you guys notice, we're also forming two angles within the circle based on those two intersecting lines. We have angle ABC and angle EBD. Now what I'm highlighting with yellow here, if we can kind of recognize that those are vertical angles, right? So right off the bat, we know, okay, if this angle is 28 degrees, I know for a fact this angle opposite is also going to be 28 degrees. And then you notice how there's arcs being formed around the circle. We have arc AC and we have arc ED, both minor arcs. Now going and looking at some of the information that the questions are asking us, it says, what is the measurement of angle ABC? So going from A to B to C, that angle there is 28 degrees. So I can fill that in. That's kind of just given information, right? And then the second part is asking us what's the measurement of arc AC, right? The arc symbol and the two letters A and C. So arc AC here is labeled as 30 degrees. And now the question is, what's the measurement of arc ED? So if you guys look at the neon orange here, that's not labeled. The way we can calculate that is going back to the idea of the interior angle theorem. And what that tells us is that these inside angles here, so the 28 degrees and 28 degrees, are formed by the average of the two intercepted arcs. So meaning adding arc ED plus arc AC divided by 2 should give us the value of these interior angles here. Now notice, guys, with this interior angle theorem, notice when these lines intersect and they form these two vertical angles, notice how that common point is not the center of the circle. If it was the center of the circle, we already would know how to find that, right? Those are called central angles, where the angle is in fact equal to the arc it intercepts. So here, I'm not just going to say, okay, well, this is 28 degrees, so is this, or since this is 30 degrees, so is this. We actually have to calculate that. So what we're going to do is I'm going to mark this as X because I don't know what it is I'm trying to solve for it. So meaning when I average these two arcs, so I add the green arc plus the orange arc, so I'm going to do 30 plus the unknown arc X divided by 2, because that's what it means to average two numbers, right? That is going to be equal to this interior angle here, so 28 degrees. Now solving for that is just undoing a two-step equation here. So to first get rid of the 2 in the denominator, I'm going to multiply by 2 on both sides. The 2 cancels on the left-hand side, and I'm just left with 30 plus X is equal to 28 times 2 gives me 56, and now I have a one-step equation to solve for X. I'll subtract 30 on both sides, minus 30, and I get X is equal to 26 degrees. So the measurement of arc ED, we just calculated to be 26 degrees. Okay. Now in the next example, it's the exact same concept, but now they're asking you to solve for the interior angle. So they're not giving it to you like they did in the first example. But notice how they're giving us the two arcs being intercepted, the orange arc and the green arc. So then all we have to do is average those two numbers to figure out what those interior angles are. But before we do that, let's just fill in our missing information here. So it's asking for the measurement of arc LN. So here's arc LN. They're labeling that as 49 degrees. And that's just given information. And then the measurement of arc OP, again, that's labeled as 53 degrees, given information. Now to find the measurement of angle LMN, so again, these yellow angles here, we're just going to average these two arcs. So what we're going to do is 49 plus 53, and then simply divide it by 2. So if you guys want to take your calculators, or if any of you guys want to do the mental math here, so 49 plus 53 gives me 102. And then 102 divided by 2 gives me 51 degrees. So meaning these interior angles here, because they're vertical angles, those are both going to be 51 degrees. All right, and the last theorem here, so we just did the interior angle theorem, and now we're going to do the exterior angle theorem. Now the reason why I'm doing these both in the same video is because your Mathia workspace combines these two concepts. They're not separate workspaces, and they're pretty similar in terms of how you solve them. So a couple things again before we kind of go to solving here. Notice now how I have array CA and ray CE, and they meet at the common point, or the vertex, right? The vertex is just that middle point of the angle that actually forms the angle, is now outside of the circle, hence the exterior angle theorem. So this angle is now working with outside of circle T, okay? So looking at our information, it's saying find the measurement of arc BD. So I'm looking for BD, here it is, and the arc is 32 degrees. And then the measurement of angle BCD, so angle BCD, highlighted here with the yellow, is 18 degrees. And they're asking us to find the measurement of arc AE. So it's going to be very similar math, guys, but instead of adding the two numbers and dividing by 2, you're going to find the difference between the big arc and little arc and then divide by 2, and that will give you your external angle. So again, in this case, since I'm solving for arc AE, I'm going to label that within X, okay? So it's big arc minus little arc in terms of the arcs that are being intercepted by the two rays being formed here, okay? So I'm going to do my little arc, so the green arc, X, minus the smaller one, which is 32, and then divided by 2 is going to equal that external angle, which we have labeled here as 18 degrees. Now, once again, solving it's going to be the exact same way you guys solve for the exterior angle theorem, a quick two-step equation. So to get rid of the 2 in the denominator, we're going to quickly multiply by 2 on both sides. Those 2 cancels. I have x minus 32 is equal to 18 times 2, which is 36. And then to get x by itself, I'm just going to do the opposite of minusing 32, which is adding 32 to both sides, meaning x is going to equal 68 degrees. So meaning arc AE here is 68 degrees. Okay? And again, another case is now where they give you the 2 arcs and they're asking you to solve for that external angle. Once again, it's the exact same process where I'm going to do the big arc minus little arc, divide by 2, and that should equal my external angle. So this actually could be quick mental math for you guys, right? So 16 minus 30 divided by 2 is going to equal that external angle of MNO. So 60 minus 30 is 30, and then 30 divided by 2 simply is just 15. So I kind of skipped my fill in the blanks here, but we can quickly fill those in together. So the measurement of arc LP, here's arc LP highlighted in green, that's 60 degrees. The measurement of arc MO, that's labeled as 30 degrees. And the work we just did up here to solve for this external angle, angle MNO, right? We did big arc minus little arc divided by 2, and that gave us that 15 degrees there.